in this question, let's see what they have said. They have asked what is the equation of auxiliary circle of the ellipse. The equation of ellipse is x square by 12 plus y square by 18 is equal to 1. Now guys, to find the equation of auxiliary circle, what do I have to find first? Well, there are two things. We know that center of auxiliary circle will be same as center of the ellipse, isn't it? And since the ellipse is in its standard form, we can say directly that the center here will be nothing but origin. That's correct. So my center of auxiliary circle is also origin. Let me take that point as O, 0, 0. Further, what is the radius of auxiliary circle, guys? Well, radius of auxiliary circle is nothing but length of semi-major axis of the ellipse. That's correct. That means I have to find here what is my A and B, and accordingly I can conclude which will be the semi-major and which will be the semi-minor one, isn't it? So we can directly say by the equation of ellipse that A here will be root 12 and B here will be nothing but root 18. And we know here that B is greater than A. This will be a vertical ellipse, right? And if it is the vertical ellipse, the auxiliary circle will pass like this. Its center will be origin, but the radius will be equal to the semi-major axis. In this case, we can say the radius will be equal to B, which will be the semi-major axis, isn't it? We can also mark the extremities of major and minor axis for the ellipse. We can say that the extremities of minor axis for the ellipse will be nothing but 2 root 3 comma 0 and minus of 2 root 3 comma 0, right? The extremities of minor axis. Similarly, my vertices will be 0 comma 3 root 2, 0 comma 3 root 2 comma 0 comma minus of 3 root 2. These are the vertices. Clear? Okay. Now this will be the ellipse, and we have just seen that the auxiliary circle will have the center same, but the radius will be the semi-major axis, that is B here. So if I have to write the equation of auxiliary circle, we can directly write the equation in which form? Center radius form. That's correct, because we have the center and the radius, that is nothing but B, and here we know that B is 3 root 2. So that means I can say that my equation of auxiliary circle will be x minus 0 whole square plus y minus 0 whole square is equal to 3 root 2 whole square, isn't it? A simple one. And when we expand this, it's going to come out as x square plus y square is equal to 18, and this will become the final answer. Have you understood? A really simple question, isn't it? Very well. And if we see the options here, we can say that B is going to be the right answer. Understood? Perfect. Well, moving further, in this question, what they have said is, what is the eccentric angle of point of intersection of ellipse which has the equation x square plus 4y square is equal to 4, and the parabola x square plus 1 is equal to y? Is the eccentric angle pi by 4 or pi by 2 or pi by 6 or pi by 3? Right? That means to find the eccentric angle, I have to definitely solve parabola and the ellipse, isn't it? So the ellipse part, when I actually convert this into the standard form, it's going to come out as x square by 4 plus y square is equal to 1. Right? I have divided the entire equation by 4, and from here I can say one thing, that A here will be 2 and B here will be 1. That means it is going to be the horizontal ellipse. And guys, what is the center? The center is origin, isn't it? So my ellipse is going to be like this. I have a horizontal ellipse, and quickly I can write vertices and the extremities of minor axis, right? What are the vertices, guys? Well, they are plus minus 2 comma 0, isn't it? So my vertices here will be 2 comma 0 and minus 2 comma 0. And similarly, my extremities of minor axis, let me take those coordinates as B dash. Here it will be 0 comma 1 and B here will be 0 comma minus 1. Clear? Okay, center is already given to me, that is origin, because it's in the standard form. So we have the ellipse with us. Now I'll solve the parabola and the ellipse, and let's quickly find what is the intersection point. So when I do that, I'll just substitute my y value, my x value in the equation, right? So when I do that, it's going to become y minus 1 plus 4y square is equal to 4. Have you understood? I have just substituted the x square value from parabola in the equation of ellipse. And this is going to give me a quadratic equation, which is nothing but 4y square plus y minus 5 is equal to 0. And guys, we can just factorize this part, right? So what are the factors? The factors here will be 4y square plus 5y minus 4y minus 5 is equal to 0, and it's going to come out as 4y plus 5 multiplied by y minus 1 is equal to 0. Clear? So from here, I'll have y coordinate as 1 and minus 5 by 4. But what values are actually possible and which value are not possible will be given by if I substitute y value in the equation of parabola. So when I put my y value as 1, it's going to become x square plus 1 is equal to 1. That means my x is 0. That is going to give me 1 point, that is extremity of minor axis only, that is 0, 1, right? And if I substitute y value as minus 5 by 4 in the equation of parabola, it's going to give me x square plus 1 is equal to minus of 5 by 4. But here we can see that x square value is coming out as minus of 9 by 4. That means this is not possible. So only intersection point will be 0, 1 and the parabola will be mouth opening upwards, right? This will be the parabola. Now, if I have to find the eccentric angle, I have to write the point in which form? Parametric form. And what are the parametric coordinates for ellipse? Well, it is a cos theta, b sin theta. We have a and b with us. A here is 2, b here is 1. And the point is 0, 1. So now I am comparing 0, 1 with the parametric form, that is 2 cos theta, sin theta. Is this clear? To find the eccentric angle, we have to compare the point with the parametric form. And guys, quickly tell me what you are getting the value of theta from here. Well, we can directly say that cos theta is 0, sin theta is 1. That means theta has to be pi by 2. This will be the eccentric angle of the point of intersection. Understood? Very well. And if we see the options here, we can say that B is going to be the right answer. Clear? Perfect. Well, moving on, this question says the equation of curve whose parametric equation is given to us. X is given to me as 1 plus 4 cos theta and y is given as 2 plus 3 sin theta. Theta can take all real values. Now to get the equation of curve, that means I have to find the Cartesian form, right? In terms of x and y, and definitely I have to eliminate theta, right? Now the question is, guys, how do I eliminate theta? Well, by the information, I can find the value of cos theta and sin theta, isn't it? In terms of x and y. And tell me one thing, guys. If I have cos theta and sin theta with me, how can I eliminate theta? I mean, is there a relation between cos theta and sin theta? Well, you are right. What is the relation? Cos square theta plus sin square theta is equal to 1, isn't it? So that is the whole thing which we have to do here, and start writing with me. Here I am going to find the value of cos theta and sin theta first and quickly put in the relation. So from here cos theta, I can say that it will be equal to x minus 1 by 4. Similarly, my sin theta value will be nothing but y minus 2 by 3. Isn't it? And now we are putting in the relation that cos square theta plus sin square theta is 1. C is for cos, S is for sin. Clear? So when we substitute that, it's going to give me x minus 1 whole square by 16 plus y minus 2 whole square by 9 is equal to 1. And actually we have to expand this. So quickly when I take the LCM, it's going to become like this. Clear? 9 times of x minus 1 whole square plus 16 times of y minus 2 whole square is equal to 144. And on expanding further, we know that x minus 1 whole square can be written as x square minus of 2x plus 1. Similarly, you can also expand y minus 2 whole square. Guys, if you haven't started, start now and let's quickly find the answer. So it's going to become plus 16 times of y square minus 4y plus 4 is equal to 144. And when I collect the terms here, I can say that I'm going to get 9x square. Then I'm going to get plus 16y square. Similarly, 9 into minus 2x is going to give me minus of 18x. And 16 into minus 4y is going to give me minus of 64y. And when I combine the constants, it's going to become 9 plus 64 minus 144. And guys, what is 9 plus 64 minus 144? Well, it's going to be minus 71, right? So I can say that my final equation is going to come out as 9x square plus 16y square minus 18x minus 64y minus 71 is equal to 0. And this will be the final answer. Have you understood? We have just expanded the equation and remember how cos theta and sin theta are eliminated by the relation cos square theta plus sin square theta is equal to 1. Understood? Very well. And if we see the options, we can say that B is going to be the right answer. Clear? Perfect. Well, moving on. The next question here is, it says, the line passing through the extremity A of the major axis and extremity B of the minor axis of the ellipse x square plus 9y square is equal to 9 meets the auxiliary circle at a point M. Okay. Further, they have said, or let us say they have asked, area of triangle with vertices A, M and origin O. Origin O here will be the center for both the ellipse and the auxiliary circle, right? Okay. Now guys, let me tell you one thing. This question they have asked in JEE Mains. Yes, few years back, but as we have already seen, we don't have to panic. This is actually a very simple question. But let's start with plotting the figure, right? That is what I love in coordinate geometry. So let's do that first. So the ellipse in its standard form can be written as x square by 9 plus y square is equal to 1. And you already know here that A is 3 and B is 1, right? That means we have horizontal ellipse with us, okay? So which here we have a horizontal ellipse. Let us say it goes like this. The extremity of major and minor axes are A and B, which they are talking about. Then we have auxiliary circle here. So let us say this will be the auxiliary circle. You know the radius of auxiliary circle is length of semi-major axis. So this is my auxiliary circle and they are saying that there is a line passing through A and B and cutting the auxiliary circle at a point M. So let's say this will be the line which they are talking about and this point here is going to be M. And what they have finally asked, area of triangle AOM. This is the area of triangle we have to find. Clear? Okay. Now guys, we can quickly write the extremities of major and minor axis for this standard ellipse, right? We can say the extremities of major axis will be 3, 0 and minus 3, 0. While for the minor axis, it will be 0, 1 and 0, minus 1. Is this much clear? We have seen the standard equation of ellipse, which is x square by 9 plus y square is equal to 1. Now I have to get area of this triangle OAM. Now guys, for this, what am I going to do here is, I will actually drop a perpendicular from this origin to the line AM. Right, if I can get this length, let us say if it is P, the perpendicular distance and length of AM, I can directly write the area of triangle in terms of half of base into height, right? This is what we are going to do. Okay, so to find this distance P, I have to get equation of AM, isn't it? If I have my equation of line, I can directly write its distance from origin. So to get equation of line AM, we can directly apply 2-point form. We have points A and B. So guys, start solving with me and let's get AM first. So my equation of AM is going to come out as y minus 0 is equal to the slope, that will be 1 divided by minus 3 multiplied by x minus 3. And if we actually resolve this, it's finally going to come in this form, x plus 3y plus 3, x plus 3y is equal to 3. This will be the equation of AM. Clear? Okay, so now I have AM with me. So what I'm going to do next is I'll find the perpendicular distance of origin from this line. And see, if you see the figure very clearly, it's shown that AM is chord of the circle. And we know if I drop a perpendicular, it will bisect the chord, right? So I can do this. Let me take the midpoint of the chord as N. And we know that ON will be perpendicular to AM. So now I have to get ON. And also I have to get AM. These two quantities I need to get the area of triangle. Clear? So let's start with ON first. For ON, I have to apply distance formula between origin and a line. And you know what is the distance between a line and origin? It's mod of C divided by root over A squared plus B squared. That's correct. So from here, I can directly say that my ON will be C divided by root over A square is 1, B square is 3 square. And it's going to become 3 by root 10. Clear? So my ON has come. Now I have to find AM, and for that we are going to do one thing here. I am going to apply Pythagoras theorem and let us say my triangle OAN. In this triangle I am applying the Pythagoras theorem. So I know OA. OA definitely is my radius for the auxiliary circle, that is 3. ON I have just find out, and AM can be brought from here, right? So I can say that my OA square, that is 3 square, will be equal to ON square plus AN square, isn't it? And from here, when I put the values, my 3 square is 9, ON square is nothing but 9 by 10. And guys, what is AN? Well, AN can be written as AM by 2, right? So this I'm writing here directly that it is AM by 2 whole square. And from here, the value of AM by 2 whole square comes out as 81 by 10. And if I take the square root, I'm going to get this value as nothing but my AM value is going to come out as 18 by root 10. This will be the value of AM. So I have now with me ON and AM both, and I can say that my area of triangle is nothing but half of the perpendicular, that is ON. That value is actually equal to 3 by root 10 multiplied by AM, that is nothing but 18 by root 10. And if you solve this out, the final answer is going to come out as 27 by 10. This will become the final answer for us. Have you understood, guys? Is this much clear? Very well. And if we see the options here, we can say that D is going to be the right answer. So what we have just done, we have used the geometrical part. Clear? Very well. Well, moving further, what they have said in this question is there are 2 points, let's say P and D, on the ellipse having the equation in standard form x square by a square plus y square by b square is equal to 1. The center is known to us, that is the origin. Here, let's take the case A is greater than B, right? Further, what they have said, eccentric angles of P and D, they differ by pi by 2. Then the locus of midpoint of chord PD is, there are 4 options which are given to us. Okay, so since I have taken A is greater than B, we know this is a horizontal ellipse. Okay, so first let's plot the horizontal ellipse. It will be like this. We have everything with us. The center here is the origin. We also have the extremities of major and minor axis. The vertices will be a comma 0 and minus a comma 0. The extremities of minor axis is 0 comma b and 0 comma minus b. Clear? There is a point P. Now guys, since this question involves eccentric angles, I'll assume the coordinate of P in parametric form, isn't it? And guys, quickly, what is the parametric form or the parametric coordinate? A cos theta comma B sin theta, that's correct. So P is known to me. It will be A cos theta comma B sin theta. C is for cos, S is for sin. Clear? Now what they have said that there is a point D over here and P and D, their eccentric angles differ by pi by 2. Now guys, that doesn't mean that OP and OD will be perpendicular, right? These are different things. The only condition is that their eccentric angles differ by pi by 2. So if my P eccentric angle is theta, I can take my D eccentric angle as pi by 2 plus theta. Clear? Okay. So this is my eccentric angle of point D. Understood? Very well. Now what? We'll take the midpoint of this chord PD as M. I'm taking the midpoint of this chord PD as M, and this locus of point M I have to find in the question. Understood? Very well. And we have already seen one thing, that my eccentric angle of D is pi by 2 plus theta. Now we have seen the parametric coordinate. It's A cos theta comma B sin theta. So guys, quickly can you write for me what is the parametric coordinate of point D? Well, the point D will be again A cos pi by 2 plus theta. And what is cos of pi by 2 plus theta? Well, we know that it is minus A sin theta. So here I am writing minus of A sin theta. Similarly, it is going to become B sine of pi by 2 plus theta. And guys, what is sine of pi by 2 plus theta? Well, it is cos theta. So my y coordinate is going to become B cos theta. Understood? Okay, so I have D coordinate with me, I have P coordinate with me, I have to find the midpoint. So I'm taking the midpoint coordinate, let us say as H comma K, since I have to find its locus, and you know the formula for midpoint. It is x1 plus x2 by 2 comma y1 plus y2 by 2, that's correct. So guys, quickly let's put that. It's going to come out as point x1 plus x2 by 2 is going to become A times of cos theta minus of sin theta by 2. Similarly, y1 plus y2 by 2 is going to become B times of sin theta plus cos theta by 2. And now I'm going to just equate the x coordinate and the y coordinate. So I'm going to get, when I equate h with the x coordinate part, it's going to become 2h by a is equal to cos theta minus sin theta. This is one condition. Similarly, let me take this as 1. Similarly, I'll have another one when I equate the y1, that is k is equal to the y coordinate part. So I'm going to get 2k divided by b is equal to sin theta plus cos theta. This is my second. Now, again, we have a relation in sin theta and cos theta, guys. And actually, tell me, how do you solve it? Well, we have only one relation which is known to us, that is cos square theta plus sin square theta is equal to 1. Right? And for this, we are going to do squaring here. Yes, I'm going to actually write 1 square plus 2 square. Let's see what do we get. So when I do 1 square plus 2 square on my left hand side, what am I going to get? Well, it's going to become 4 times of h square by a square plus 4 times of k square by b square. And on the right hand side, it's going to become cos theta minus sin theta whole square plus cos theta plus sin theta whole square. Clear? So quickly expand this. Cos theta minus sin theta whole square, well, it's going to become cos square theta plus sin square theta, which is 1, minus 2 cos theta sin theta. Similarly, when I do cos theta plus sin theta whole square, it's going to become cos square theta plus sin square theta. That is again 1 plus 2 sin theta cos theta. And we can see very clearly from here that 2 cos theta sin theta is getting cancelled out and I'll be left with only 2. So I'm going to get the final answer something like this, 4 times of, now in place of h, I can write x. And similarly in place of k, I can write y. So the equation will become 4 times of x square by a square plus y square by b square is equal to 2. And further I can say the answer is going to come in this form, x square by a square plus y square by b square is equal to 1 by 2. This is going to be the final answer or the locus of midpoint of chords P and D. Have you understood? Whenever the eccentric angles differ by pi by 2, don't misunderstand it like OP and OD are perpendicular. That is the common mistake, guys, which many of the students make. So don't do like this. Always take the eccentric angle of point D as pi by 2 plus theta. And then you can solve further. Clear? Very well. And if we see the options here, we can say that D will be the right answer. Understood? Perfect.